All right. There you go. The cord's ready. So basically, all the rules that you learned up to this point is the same. We're just adding an extra detail, and we're going to kind of stick to the Leibniz notation, which is the dy dx type stuff. Um, well, let's go over the this idea first before we start the homework. So, for example, given this equation in terms of x squared, y squared, and r squared, let's take the derivative of both sides with respect to x. Okay, so basically we're gonna, how do I phrase this? Let me see here. Okay, so when I say respect to x, I mean d dx of both sides. In other words, every single term. So if the variables do not match, you're going to take the derivative implicitly. So that's the whole idea. But if they do match, like for example, x squared, it's just a normal derivative. For example, let's go ahead and do our notation. d dx of this guy, d dx of this one. And of course, this is already ready. So this matches, there's just going to be 2x, not a big deal. But this guy, do your power rule like you would usually. You bring down the 2. I'm going to show the step here. Bring down the 2. The only difference is you have to add a implicit piece. So derivative y with respect to x, derivative r with respect to x. So our final answer would be will simply be this. So when you take it implicitly, you're basically taking derivative of all the variables with respect to a specific variable. If they are different, then you have an implicit part like this. Does that make sense? Like this is the new rule.
Yes, it makes sense.
Any questions? So we're gonna move on to examples in the homework. So just remember, in the homework, you're gonna take the derivative just like this, and then they'll ask for a specific dy dx or dr dx. You gotta solve for it. So the next step would be like algebra, I guess. Okay, question number 1. I don't know if this is in the homework, but I think I may have made it up. I forget. Find dy dx by implicit differentiation. So here we go. Let's do something simple first. So d dx of both sides. Yeah, since it's a dy dx, we'll have to do dx. Of every single, this one we'll just do divide it this way every term. So what is this derivative going to be? So this section is going to assume you're good at all the rules.
Which one was it?
Are you talking about the 3x squared? Would that be 6x?
Okay. So it's just a basic power rule, right? Since they match, it's just 6x. This guy will also be 6x, but, or sorry, 6y. This would be 0. Any questions about this first step here?
No.
Excuse me. Okay.
Quick question. So,
So-
why?
This is just a basic power rule, and then you tack on this implicit part. But they want dy dx, so use your algebra to solve for it. Okay, so I'm going to add, subtract these 6x over there, get the dy by itself. Divide both sides by negative 6y in the next step. So now I have dy dx equal to x over y.
Professor, I have a quick question.
Oh, okay. Let me see. Yeah, my settings are all different, so I don't know. Give me a sec. Yeah, I can't seem to hear you guys. You're right. I think. Sorry about that. Yeah, I think my speaker was set to mic for some reason. Stupid. But yeah, so what's your question, Jordan?
Can you hear me?
Yeah, I can hear you now.
Okay, cool. Um, when when okay, so the 6x minus 6y, you bring down the dy over dx. Why didn't you do it for the 6x part?
You don't do it for this one because it's with respect to X, so it's just gonna be the usual stuff that we do.
Oh, got it. Okay.
So all the
Okay,
derivatives
never
we've been
mind.
doing so far were respect to the same variable, but now we're
Mm-hmm.
doing it with respect to X, but on different variables.
Oh, okay. Okay, got it. Thank you.
Mhm. So basically, if it matches, don't do the implicit step.
Could you go over those steps you just did after e equals 0?
Yeah, let's just go from the top. Okay. So first step, d dx of every term, right? This is a constant, so it becomes 0. This becomes power rule, bring down the 2 times 3 is 6, reduce the variable by 1, right? Just power rules here. This is the implicit step. Now solve for this using your algebra. So I subtract this over here, divided both sides by negative 6y to isolate this. Right? They cancel, solving for dy dx. So basically this is like your y prime. But it's implicit because I still have a y over here. That's what they mean.
Okay, thank you.
And that x over y is what we're aiming to get, right, as our final answer?
Yeah, you're trying to isolate dy dx. That's what you're trying to do. So that answer everyone's questions or any other questions?
Oh, sir, I had a question. So you were saying that that dy over dx is like saying it's your y prime. I want to ask,
Mhm.
what's the difference between having like a y prime and having an f prime of x?
There is no real difference. It's just prime means the derivative of that variable.
Okay,
F
thank
prime
you.
would be the derivative of the function f. That's all.
Sweet, thank you.
Yeah, no worries. Yeah, there's a lot of little notation and that kind of gets that's all over the place, but so like y prime of x is basically the derivative with respect to x of y, which is your dy dx. Okay, let's do another one. So it's going to be the same thing over and over again. It's just the amount of algebra and derivatives will become more complex. But in essence, this is what you're doing. Implicit derivatives and then solve for this. Like I know big picture that sounds easy, but the derivatives in algebra can get gross sometimes. You know how it goes. I'm sure you saw it on the chain rule if, you're there. All right. Here's another one. Find dy dx by implicit differentiation. And I'll go ahead and help y'all out and extend the homework. That way I can let you work during on Thursday, since we're not having a lecture for chapter 3. Okay. Okay, so here we go. D dx of every term. Excuse me. So notice this is a product rule, right? So this will be derivative of the first piece times the second piece plus the derivative of the second piece times the first piece here. Then this part will be the same, but I'm out of space. 4y squared first piece times the second plus du dx of x times 4y squared. We'll just write this on the bottom. And then derivative of this obviously is a 0. Sorry, that got a little messy there. You guys still with me? Okay, so derivative of this guy is just a power rule. That would be 10xy plus derivative of this will be 1 times dy dx. So this is our implicit piece. Times this garbage. Derivative of this will be 8y times dy dx times x plus derivative of x is a 1 times 4y squared equals to 0. All right. You guys see the derivative step? It's a little messy, so let me know. So at this point, we're just going to do algebra, solve for these guys. So just factor dy dx. So get the ones with the dy dx on one side, everything else on the other side. So I'm gonna leave this stuff right here. I'm gonna skip some basic algebra. If it bothers you, let me know. I can show more steps. I'm not gonna. So anything that does not have dy dx is gonna be moved to the other side via addition or subtraction, just depending. So this would be negative 10xy minus 4y squared. I just move this guy over there and this one over here. You guys cool with the algebra?
I'm good.
Yes.
All right, 1 second. Interesting. Okay, so factor dy dx, and we're pretty much done with this problem here. Be 5x squared y plus 8y equal to this nonsense. So dy dx is equal to negative 10 xy minus 4y squared over 5x squared y plus 8y. So I just divided this over there. So I skipped some algebra steps so you're not you know, not so we're not writing too much, but if you have any questions on it, let me know. All right. Okay. So not too bad, I hope, or is it so horrible you have no opinions? Okay. Let's see here. All right. That's good. Let's move on to another one then. Let's use this equation here. So remember that this is technically xy to the 1/2 equal to, right? The square root, just change it to this and do a power rule. Technically, that's going to be a chain rule with a product that's also implicit. Oh well, oh well. Life sucks, right? Okay, here we go. X cubed y plus d dx of 14, so every single term. So then do your power, your chain rule on this guy, product here, and this is just 0. Okay. So derivative of this is going to be, this is going to be the annoying part. Times derivative of this, right? I'm going to put a quote, just remember this is with respect to dx. Derivative of this is going to be d dx of x cubed times the y plus d dx of y times the x cubed plus 0, but it's unnecessary, right? So this will be 1 over xy to the 1/2. I skipped a step there. But this is going to be -1/2, so it's going to come down, right? Is that okay to skip?
Yes.
Okay, just let me know if you want more elaboration. This will be a product rule, so this will be times derivative of this is 1 times y plus derivative of y is dy dx times x. So there's the product. So that's this implicitly. Then derivative of this would be 3x squared y plus derivative of this guy will be dy dx times x cubed. Okay. You guys up with me up to this point? Nobody afraid to ask questions because that's why you're here.
So the derivative of the xy is that why you separated it to the 1x? So you took
Yeah, derivative
x
of
turned into
this one
1
here.
and y. Yes.
Yeah, it's gonna be this.
Where did you get the dy dxx? Is
So-
that the, is that the, derivative of XY? Is that what that is?
Yeah, this is this is a product, right?
Okay,
So you gotta do a product rule. So basically, you see how I did this over here?
okay, I
I
see
showed
it
the
now.
in between step, but I didn't show it there.
Okay, I see it now, thank you.
You see it? Okay. Alrighty. Everything. Okay. You guys have any other questions? All right. I'm gonna go ahead and distribute this. This will become y over, I'm just gonna write it as a square root just because it's easier to write. No other reason. This doesn't look very pretty though. Oh well. All right. So everything with UIDX will be moved to one side, everything else go to the other. We'll factor and divide just like before. Okay. I know looks kind of nasty. Yeah, I don't know. It may have looked slightly better if I left it as a negative half. I don't know. It's just a matter of opinion, really. If you don't like seeing these fractions, I should have left it up here, negative half. But it's all the same. Do you see what I'm saying? Here, you know what? I'm gonna rewrite this step just because I feel there's at least one person in here that hates this. You'll see what I mean. Again, there's nothing wrong with this. I just think it'll look easier on your eyes if I do it like this. Maybe, I don't know. Maybe it's still horrible. So multiply this times this. That will be y times x, y, the negative half over 2 plus dy dx times what's it better? Because y'all can tell me if this is any better. I feel like maybe not. Again, it's just opinion. So what do y'all think? This any better? Or is it the same thing for you?
I like the first way better.
Yeah, first one. Okay. So just for fun, right? That was just for fun. So either use this or the way we had it. Does not matter, does it? That way you can adjust if you want to. There's both. Okay, anyway, just getting sidetracked here. So move everything without dy dx over here, and this one will be moved over there. Okay. So I'm going to skip the algebra step, and if you want to see it, you let me know. I don't want to, I mean, you should be algebra pros, but I know that's not true. So you tell me if something weirds you out. Okay. And then factor dy dx, leaving you with a bunch of nonsense. I'm out of space. Okay. So just divide this thing over here and we're pretty much done. Yeah, it's fine. This is so the solution will be this. Yeah, I'll have to write on the other side. All right. Any questions on this algebra? You could multiply top and bottom by 2 roots square root xy, just for fun. So multiply by 2xy over 2xy. It should take the top one, but if it doesn't, we'll distribute this top part here. That'll give you a 6. 3 times 2 is a 6. x squared y square root 2x. Sorry. Square root of xy. These two would cancel, leaving me with a minus y over. This would turn into x minus x 2x cubed xy. Anyway, so since we have a complex fraction, you can cancel all the fractions to make it into a regular fraction. I don't know if it'll take this, but this should be good. Anyway, it's just algebra, right? You can mess with it all day. Do you have any questions on the process? Okay. Do you guys have any, I guess let's pause here.